Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Till then, let me turn on my preview screen to verify if I'm visible or not. Just let me see. Okay, I'm fairly visible as well as equally audible. So if you are watching the video, just like the video and just ping me something. At least a +1 would solve the purpose so that I know that yes, you are present. Okay, till then let's just have a timer of 1 minute. Or 30 seconds. So we would just wait for the next 30 seconds and we would start right away. Okay, so let me just see and refresh the screen. Okay, thanks a lot, Akash. Okay, so 1 minute have passed. Now let us jump to the solution. Okay, today we would be discussing yesterday's problem of the day, that is corona vaccine. This is a problem of tree and this is a hard level problem and the success percentage of this problem is 72%. Okay, now let us move and understand the problem statement. So we are given, so Geek has developed an effective vaccine for coronavirus and he wants each of the N houses to have access to it. So basically the summary of this line is there is a vaccine that is kind of made or rather invented, okay, or rather prepared, and he wants to distribute all the vaccine to everyone. Okay, एक वैक्सीन है जिसे बनाया गया है और n हाउसेस है, हमें सारे हाउसेस में वो डिस्ट्रीब्यूट करना है. Okay, so we are given a binary tree where each node represent a house in the geek land. So we are given a binary tree. Now what is a binary tree? A binary tree is a tree which have at most 2 children or less than 2, that is 0 or 1. So basically a particular node can have 0 children, that means it is a leaf node, can have 1 children, that means only the left or either the right. Okay, or have 2 children, that both the left and the right is present. Okay, and we need to find the minimum number of houses that should be supplied with the vaccine kit. If one vaccine is sufficient for this house, of its parent house, its immediate child nodes. Okay, so let's understand the last line a little bit more, okay, so that you would get a proper understanding of this. Okay, so let me just remove this. Okay, now suppose there is a particular node, okay, and it has 2 children. Okay, again this is the root node. Okay, so basically this is the root node. I would just write a root. Basically it doesn't make any sense still. Okay, so it is told that if we provide the vaccine to this node, then the people that would get vaccinated are the parent, this one parent, and its immediate child nodes. Okay, if there are more branches present, suppose this, these all won't be vaccinated. Okay, fair enough. So if we vaccinate, if we provide the vaccine to the last node, then its parent would be vaccinated. Okay, but the left and the right is not present, that is the leaf node. So basically there would be no left and right node. So it would be vaccinated and its parent. So if it is present, so if the parent is present, it would get vaccinated. If the child is present, it would also get vaccinated. Fairly, this is the proper reason of that. Okay, now moving forward with this. Okay, now suppose let us first discuss this. Okay, now suppose we have a particular node. So if we have this type of structure, then we need how many vaccine? Okay, basically this is quite, you would be encountering this type of thing quite a few number of times in binary tree. So let's discuss this. So we can either, okay, then if we vaccinate this would get vaccinated, and we need to explicitly vaccinate the next one. So we need 2 vaccine, okay, in total. So 2 vaccine if we do this. Next, if we vaccinate this one, then this one would get vaccinated, and the same story we need to get explicitly vaccinate this one. So again a 2 vaccine is needed. Then let us move to the last one, that is this one. And it is quite easily understood that if you vaccinate this one, its immediate next child node would get vaccinated, that is this one and this one. So basically we can have many ways to vaccinate. There is only not one way to vaccinate, and we have many ways to vaccinate. We can either vaccinate the parent, we can either vaccinate the child, or we can either vaccinate the particular node itself. Okay, there are 3 options. Okay, this is it, and we need to supply the minimum one. Okay, this is it. Now let me just remove this, and let me just copy this one, okay, in the next page, so that I would be making it a little bit large. Okay, fairly, this is it. Now what I can do is, I can start vaccinating from the lower part, or I can start vaccinating from the upper part also, whatever is fine with you. Okay, we would see what are the different scenarios. So if we vaccinate this one, so this would get vaccinated, but if we vaccinate this one would also get vaccinated, and this one would also get vaccinated. So basically we can see that vaccinating the parent is always a better or the same. Okay, so if the tree is like this, then vaccinating either the parent or the child is same. Now if we are vaccinating like this, then vaccinating the child would be costly. So we can draw many other scenarios, but these are the only 2 possible scenarios. Either it has a leaf node. If it is a leaf node, then either of the case there is no child or the parent type relation, so we need to vaccinate this node only. So we don't have much option, but in this we have the option to either vaccinate the parent or the child. So we can see that in both the scenarios, the vaccinating or giving the vaccine to the parent node is not producing any loss. It can either be same or it can be much beneficial, not less. Okay, we can see that. Okay, now it can be properly understood that if we vaccinate this one, this 2 would get vaccinated. So these 2 are the effect of this vaccine, and these 2 are the effect of this 2 vaccine. Okay, I hope this is clear. If this is clear, just send me a quick +1 in the chat. Okay, and I would know that this is clear or not. There are 7 people watching right now. Please like the video if possible, and let me know if this thing is understood or not. Still, I would just have a timer turned on for the next 30 seconds, I suppose. If we just quickly tell me, then I can move forward without waiting for the next 30 seconds, sorry. So quickly tell me if things are clear to you or not. Okay, Lalit, thanks a lot. Thanks a lot, Akash. Okay, thanks a lot, Mehul. People are replying, so let's wait till a little more. Okay, I might get a doubt. Okay, it seems so. Okay, So I think 45 seconds is much enough. We are vaccinating from both sides. So basically, see, we have three ways. Either we vaccinate the left. So if it has both left and right child, let's take the largest population. If it has both the left and the right child, and it has parent also. So we have two options. Either we have three options. Either to vaccinate the left child. So we saw that vaccinating the left child and the right child is same. And if we vaccinate the parent child, then it would always bring us the same result or better result. मतलब अगर पेरेंट को वैक्सीनेट करेंगे ना तो उसके चिल्ड्रन तो वैक्सीनेट होंगे और पेरेंट को भी करने से चाइल्ड को भी करने से पेरेंट होंगे. ओके, मगर पेरेंट को करने से एक फायदा ये होगा कि उसके चाइल्ड और उसके भी पेरेंट सारे वैक्सीनेट हो जाएंगे. सो उसका फुल पोटेंशियल हम लोग निकाल पा रहे. दैट इज वाई कंसिडरिंग द पेरेंट is much beneficial. This is the reason. Okay, so let's move forward and we would see. Okay, so now suppose I have a binary tree. Okay, I have a binary tree like this. By the way, this question is a charm. This question has not appeared in any of the coding contest, but this question does provide you a very good grip over trees. Are we going to use flood fill algorithm to find the solution? No, we won't be doing the flood fill algorithm. What is your, and after you read the problem, what is your intuition? So I thought something like post traversal, but then I thought that I can consider either the parent, a child, or the left and the right and the parent. So whenever I see that there are three options and I need to take out the minimum out of it, I always first think of greedy. If I can't find the greedy solution, then I move to recursion and then I memorize it and then write a iterative. This is my way of solving a particular problem. Okay, now let's move forward and let us try to understand. Okay, so now suppose this is the binary tree that is given. Now we need to vaccinate this one because no one can vaccinate this. But suppose I want to take a decision for this one. I want to take a decision for this one. Basically for this, I have many options. If I vaccinate this one, then I need to vaccinate this one. If I vaccinate this one and again vaccinate this one, then this need is complete, but I am vaccinating it again. And vaccinating it twice is beneficial for me. How it is beneficial? Let me show you also. Suppose I vaccinated 2 times. So because of this, this would get vaccinated, and because of this, these 2 would get vaccinated. So I would require 2 vaccines. Now suppose I vaccinate this one and I vaccinate this one. So vaccinating this one would vaccinate this one and this one, but this won't be vaccinated. So basically we would require 3 vaccines. Okay, so we can see that vaccinating twice can also be a better scenario for us. Okay, so we need to consider. Okay, so what can we consider is we need to vaccinate. Okay, we need the vaccine, or we are done. Okay, we are done with the vaccine. So basically 2 ही कंडीशन हो सकते हैं कि either वैक्सीन मिल चुका है और either वैक्सीन मिल चुका है और either ज़रूरत है. This is the 2 condition that we knew. Okay, now suppose let us understand. Okay, suppose we have a tree like this and we vaccinate this one. We vaccinate this one, but this one is not vaccinated. So if this one is not vaccinated, then whatever be the condition, we need to vaccinate this one in order to vaccinate this one. Why we are vaccinating this one, not this one? Because we told that vaccinating the parent is always a better alternative, or this alternative would provide us the same result. So basically we would always go with the parent. We would prioritize the parent first, then we would go to child. Okay, fair enough. So basically this can be the condition. Okay, now let's take one more condition, that first we are need. Okay, and then we are done. Now what can be the other condition is, suppose we have a structure like this. Okay, we have a structure like this. Then if we vaccinate this one, then because of this, this would get vaccinated, this would also get vaccinated, this would also get vaccinated. So the third scenario would be either I need a vaccine or either I'm done with the vaccine. The next is that I would be given the vaccine by my family members. Okay, so I have within family. So I would just write within family. Or let us to make it more appropriate, I would just write famjam. Okay, famjam. Okay, now I hope things should be clear. Let me make it this side. Yeah. Okay, now the three conditions are either we need a vaccine or we are done with the vaccine or someone in my family is providing me the vaccine. Okay, now what can be this? Now what we need to do is we need to handle three types of scenarios. Okay, we need to handle three types of scenarios. So if we need a vaccine, we would increment the answer. If we are done with the vaccine, we would not increment the answer. So the incrementation or the decrementation would be 0. Or if we are getting the vaccine from any family members, the need of the vaccine would be 0. Okay. Now tell me if things are clear to you or not. When we need to increment the number of vaccine, when we are not incrementing the number of vaccine, okay, and why we are prioritizing the parent. These all things are clear to you or not. These are the things that we have discussed. Tell me at which point you are not able to understand. Then we would move forward. Okay. We are going to, okay, what is it? Okay, makes sense. Okay, just quickly tell me if things are clear to you or not. I don't think that I need to have a timer for this. Quickly just reply 2 or 3 and then we would move forward. Just one more reply to my question and then I would move forward. And if you have any queries, quickly reply. Quickly do it. Okay, we have one person. Quickly, someone else. Just quickly reply Mehul or Srihari or someone. Or Satendra. Quickly reply, someone just reply so that I move forward. We have a lot of viewers. So please like the video if possible. I think my chat needs to be updated. Let me just check. Okay, fair enough. So I don't see any doubts coming in. So rather I was waiting for doubts. So what can be done is we can say that if we need a vaccine, I would return 1. Okay. If I am done with the vaccine and I don't have any extra vaccine, okay, so I would say that I am done with the vaccine and I can't provide anyone else. So if I am a relative and I can suppose I got vaccinated, so I can vaccinate my family members, so I can say that I have an extra vaccine. So let's make it -1. Okay. So if we need a vaccine, so it would be -1. If I am done with the vaccine and I can't provide to someone else, then 0. That मैं इस game से बाहर हूँ. Okay, मेरा इसमें expertise नहीं है. So FAMJAM, it means that I have taken the vaccine and I have the potential to vaccinate someone else. Okay, so one more 0. So let's quickly write it. Okay, so this is the basic solution. Okay. Now what we would do is we would have an external, we would have a global variable declared. Okay, and we can increment it when we need a vaccine. Okay, now though we are talking about a tree traversal, basically we always think in terms of recursion. Okay, so thinking about base recursion, the most difficult part is, so the intermediate cases are we need to just go in these 3 directions and we are done. But the most difficult case in recursion is calculating the base case. But if we are solving a tree problem, then most of the time it is not an issue. Okay, the base case is not an issue because the base case can always be considered in terms of what? Nothing but null. Okay, when the particular node is null, the famous test case, the famous base case. So when the particular node is null, suppose there is no node. So if there is no node, we don't need any vaccine. So we would return what? Or neither we can provide any vaccine. So we would return 0. So if the root is null, we would return 0. Okay, fair enough. Then we would go to the left and the right. Okay, if any of them is bringing us -1, we would increment the vaccine counter and we would move forward. And you would get to know more properly when we would start implementing it. So to make the things more simple and more intuitive, I would be coding it live today. Okay, because recursion problems are small enough to be coded live. Okay, so let's code it then. So we are given the root of the tree. Okay, let me just make it a little bit. Okay, fair enough. Okay, I hope that this is clear. Okay, so we would take care of giving. So this would be used as passing, and we would have a wrapper function. Okay, so basically let's name it vaccine. So let's name it int v is equals to 0. Then we are returning the number of vaccine. So we are returning if we need a vaccine or not, or if we are done with the vaccine or not. To do that, we need to return an integer. So we would return an integer of, and we would take hold of what? We need the tree to traverse basically most of the time. So we have already decided that if the root is equals to null, or you can just write root not, because that would just null not would make it to 1 and you would be doing it. That's a short form of writing it, but I won't be writing it. That would just okay, make you confuse you. So if the root is null, we don't want any vaccine, but neither we can provide you any vaccine, and we are done with this. Okay, fair enough. Now comes the case that we would go to the left child and the right child. So int L is equals to recursion of root dash left. Okay, and then int right is equals to rec of root dash right. Okay, fair enough. This is what we did. Suppose I told that if any of my child needs a vaccine, okay, so I need to provide him vaccine. Basically, this is the thing. So if I got the vaccine, what was the scenario that we just discussed? Okay, we discussed that if we need the vaccine, it would be -1. Okay, fair enough. If we need the vaccine, it would be -1. So if L is equals to -1 or R is equals to -1, we don't bother. See, there can be two scenarios. Either both are -1. See, even if both are -1, if the parents gets vaccinated, both the child would get vaccinated. If one of them is not vaccinated, we have no option but to vaccinate it. So if we vaccinate the parent, we can take care of all the situations. So what we would do is we would first vaccinate it. So we would increase the counter of vaccine. Then what we would do is after this is vaccinated, then this has the potential to provide vaccine to its parent. This is what we have discussed. So if it has the potential to provide a vaccine, we would return 1 at this case. Okay. So we would return 1 in this case. Okay. Now what can be the other scenario? You can write else or if both the cases would run the same, because if this if case evaluates to true, we would directly return it and the control of the program won't go down. Okay, so to make sense this thing, so to not discuss this, so let's go with this only. Okay, now we are told that if any of them, suppose he is saying that father, suppose I went to my father and I told that father, I'm earning enough to look over myself, but I'm not earning that much ki I can look upon you. So you look for yourself and I would look for mine. Okay, basically शॉर्ट में समझा जाए तो अपना अपना देख लो. So बेटे ने अपना देख लिया, अब बाप को अपना देखना है. Okay, fair enough. So if any of them is done, that is 0, but it can't provide someone else. So if L is equals to 0 or R is equals to 0, okay, then we would return what? If any of them is done, okay, so we need to vaccinate ourselves. If we vaccinate ourselves, we have the potential to vaccinate others. So we would return 1. Okay. So we would return 1. Else, what would be the case is, we either both of my child is not vaccinated. Okay. Either they are looking upon themselves but they can't look upon the root of the tree. Okay, this is the case. Now the next case is that I particularly need the vaccine. Okay, just let me look over this. So the case where both of my child, okay, so this is the first case, that any of my child needs a vaccine. Okay, suppose this is vaccinated but this is not vaccinated. Then this is the condition where my childs are vaccinated but I am not vaccinated. Then this is the condition that I have the potential to vaccinate it. Okay, so basically what we can return is, we can return 1 in this scenario also. Okay, that I can vaccinate someone else also. Okay, fair enough. Now what we need to do is, we need to pass the rec to the root enough. Okay, and then after that v would be incremented. Okay, or you can pass the v in pass by reference, and then we need to return v. Okay, this would run for sample test case, but we would fail in certain test cases. So let us just see. So expected is 0 but the output is -1. Okay, let me just check. If the root is equals to null, okay, then we don't need any vaccine. Okay, if the root is to null, okay, if the root is equal to null, we don't need any vaccine. Okay, so we don't need any vaccine, that is done. If the left or the right needs a vaccine, then we would be increasing the counter of 1 and we would be returning 1. That is, yes, I can provide you vaccine. Okay, or else this would be -1. So let us just compile and run. Okay, so now the scenario would occur when this scenario this won't work, when the scenario would be like this, that there is only one node. If there is only one node, we would be done from this side, we would be done from this side. Okay, so this side would be null. Okay, this is, so basically this won't be there. Let us not draw any node. Okay, so if this is the node, okay, and we go to the left, this is null, the left null. So basically this is 0, this is 0. So this would return 1. Okay, this would return 1, but this won't be so we won't be increasing the counter. Okay, so we want to do it explicitly. Okay, we need to do explicitly. So to do that explicitly, what we can do is, if condition, that if this root value is equal to -1, that is, it needs anything. Okay, we would be increasing the counter of this v. Okay, so are we making any mistakes at any other point? So if the root is null, we would be returning 0. Okay, we won't need any vaccine. Then we would go to the root of left, then we would go to root of right. If any of them needs to be vaccinated, we would provide them, and we have the ability to vaccinate it. Now the next condition is that they are done, but we need to vaccinate ourselves. Okay, so we need to vaccinate ourselves, so we are returning 1 at this scenario. I think we need to update our so we are taking a vaccine at this point also, so this would also be v++. Output difference, your output is 6. No, this won't be the thing. Let me just compile and run and see. Output difference is 1. So that is the problem. That is why I don't code it live, because I tend to make mistakes. So, and everyone makes mistakes. So can anyone quickly find an error that if any of them we are returning the v if the root is equals to null? we are returning 0. Okay, so quickly, can anyone tell me where I'm making mistakes? Or else I would go to my previous submissions, because I won't be debugging it. So it is 3:31. I won't be waiting till 3:32 to debug it. So, or any of them is r is equals to 0. That is, they are done, but we need to vaccinate it. So in this scenario, we would be returning true, or else if the root of the tree is equal to null. No, it's 3:32. Let's go to my previous summation only. Okay. So yeah. So where are we making a mistake? Root left, return 0. Okay. If we didn't handle the case where, suppose if any of them has the potential to vaccinate me, okay, suppose my child is already vaccinated and it has the potential to vaccinate me, then we would return 0. That so I would simply say that I don't have the power, my child has vaccinated me, I am not vaccinated. Okay, so at this scenario, and then we would just compile and run. Okay, expected to, and we would quickly do. Okay, fair enough. So we are done. So basically, this is the two condition. That the first condition was that any of my child requires a vaccine. Okay, so in that scenario, I would be vaccinating the parent. This is the condition where we are vaccinating the parent. Then the next scenario is that if any of my child is vaccinated and it has the potential to vaccinate me, then we would return 0. And the next condition would be that I am not vaccinated, I need to vaccinate. Okay, and if the root is returning -1, okay, that is, it needs a vaccine, then we are updating it. Why? Because in this scenario we are just returning, not updating. Okay, fair enough. So I hope things are clear to you. Still, if it is not clear, I would just wait for the next 1 minute to see if there is any more doubts or not. So quickly say me if things are clear to you or not. Let's wait for the last 1 minute and quickly say me if things are clear to you or not. So basically what we are doing is we are kind of traversing on 3 options. So we have 3 options, and initially it seemed that we should consider all the 3 options and take out the minimum of it. But then we found out that vaccinating the parent is always beneficial, or rather the same. So why not keep vaccinating the parent and then compute the answer? Okay, this is what we did till the last point of time. So is the iterative version complex? No, I found an easy iterative method where it was using unordered map, but I don't consider using unordered map because the thing is that unordered map has a time complexity of worst time complexity of big O of n square. Okay, this one. And if the average time complexity is big of 1, but the worst is, so we always go with worst. And the next is that, so you would say that why to use unordered map, you can use map. So if we are using map and we are iterating on all the nodes, so for each of the operation, map uses a log n operation. So for n nodes we would be doing n log n operation. So let us quickly discuss the time complexity of this also. Okay, so basically we are not doing anything, but rather traversing over to the left and the right, then this is going down, then this is going down, and we are reaching a base case, and we are hitting the base case, and then we are coming back. So we are not doing any other things. So basically this is big O of n that we are traversing on each of this. Okay, now the next iterative version is that we need to save this all answers. To save all this answer, we can't take use of an array. Okay, or we can take use of the array, but it is not feasible enough. But take use of unordered map, but I told that I have worst time complexity. So for each operation on a map, if we consider map, the lowest time complexity is log n. So if we iterate on n elements, then the time complexity would be n log n. Okay, that is why going with the iterative version is not a good option. Okay, go with the recursive one, and the time complexity as well as the space complexity would be much better. Okay, so that's it for today. Thank you and have a nice day.